Okay, so here are your 3.2 alternate examples. This one has to do with tapping soda and shaking it. First thing we're going to do is we're going to put this into our calculator in this form. So if we look at it right, each one of those is zero entries, right? For 0 taps. So we're going to enter that into our calculator like this. The question is asking to construct scatter plot, least squares regression line, and residual plot for the data. So let's go ahead and get started with that. First thing we'll do is insert data and statistics. Our explanatory variable is going to be the number of taps. Our response variable will be the amount of soda. And there we go, there's our scatter plot. All right, so here we go. Here is our scatter plot. Beautiful. All right. We can get our least squares regression line 2 ways. Okay. We can do it with our calculator. We can do 2 variable statistics, right? And we'll do it that way as well. We'll actually be able to get a nice drawing of it using our calculator. So we're going to hit menu. And we're going to analyze. And we're going to go down to regression. And you can show it in either way. You can go mx plus b or a plus bx is the same one.
Wait, how did you... Okay, go to menu.
Okay, menu. Analyze. Regression. And then these are all the different regressions that we have. I mean, just take a minute to look at all of our options. This is amazing, right? We can do quadratic regression, cubic regression, quartic regression, any sort of power regression. So we need to do regression on some 8th degree polynomial or something like that. We're only doing linear. Okay? Anything that's not linear, we will make it. We will make it linear. Yes, absolutely. We'll do those transformations. We'll talk about it later. But for now, honestly, for me, just because I'm old school, I'm gonna go mx plus b because I know it's just the way I look at a linear equation. A plus bx is the way that statistics is showing us. But I mean, as long as we know, one is our y-intercept, one is our slope, x is just our values of our explanatory variable. We can use either of them, right? So I'm going to use this one. And there it is. So not only, and if this is in your way, you can take it, you can pick it up and grab it, and move it out of the way if you want. So if you want to pick it up and grab it, what you're going to do is you're going to see that when you use your little mouse thingy, when you hover over it, you're going to see a little hand pop up. You click and hold it, the hand clasps it, and then you can move it where you want, and then you click and hold and the hand unclasps. It's pretty cool. Be careful with your claspy hand though, okay? Because if you clasp one of the points and move it, it actually changes that data value on your table. So just be careful with that. If you accidentally grab it and move it, it changes the data value. Okay. So nice. We have the least squares regression line. We know that 2.635 is our slope, and 2.4864 is our y-intercept. All right. Now I also said let's go ahead and find, look at the residual plot. Recalling that our residuals are the difference between our actual value and our predicted value, right?
Predicted values are liars.
Yep. Predicted value is any y value on the line, and then our actual value would be a y value for a recorded database. All right, let's do that. All right, so in this same screen, we will be able to add a residual. Or we could do it in a different screen. Let's add it on this screen because I like seeing them side by side. So we're going to hit menu. We're going to analyze again. And now we're going to choose 7 for our residual, okay? We're going to show the residual plot. We're not going to look at residual squares.
So the residuals exist because they are from the line.
Exactly. So mission accomplished. We have done all three things. We have come up with the least squares regression line. We have made a scatter plot. And we have looked at a residual plot. Now, let's talk about this. It looks like we have a fairly strong positive linear correlation between our explanatory variable tax and our response variable, which is the amount of soda left in the can. Based on our residual plot, it appears that a linear model is appropriate for this data. There does not appear to be any pattern, although it's weird that the data is grouped like that. But we know that it's like that just because of the way that this experiment is, or the way that this observational study has been conducted. Excellent. Looks good. We'll get plenty of practice doing more of these. Let's move on. What do we need to know next? Let's identify the slope and y-intercept of the regression. Good. So, our equation of our regression line was, can someone give me the slope, please? Sorry, I couldn't hear you. 248.64, right?
Or do you have to?
We're going to interpret it as well, but I don't want to just... Oh, my bad. That was our y-intercept. 2.635.
Yeah.
There we go. Sorry. Okay. I put it in a plus bx form. If you put it in y equals mx plus b form, it's not wrong. All right. Okay. Let's interpret each value in context. First of all, the y-intercept is the easiest one, right? Okay. The important thing to realize is that whatever is multiplying your x, right, that's always your slope, right? So it can go in either way, just as long as you recognize that. Okay, so this tells me that we expect, so for our y-intercept, we would say we expect 2.4864 ounces to the left remains. I don't know if remains for that word. Be in the can. For 0 tax. Cool? Alright, let's interpret our slope. And you need to be so good at interpreting slope, okay? You're going to be asked to interpret slope over and over again. I can 100% guarantee there will be a question on the AP statistics exam that will ask you to interpret the slope of the least squares regression line. Guarantee. It's always there. We're going to interpret this. We're going to say we expect, so first it's for our slope. We expect the amount, oops, I can spell, of soda left in the can. Right? These always have to be in context, left in the can, to increase. Very important that we're going to say that it increases or decreases. If you have a positive slope, it's absolutely going to increase, right? To increase by 2.635 ounces for each
Oh my god, really?
I'm going to say like incremental increase in taps or something like that, but I think tap just works, right? Every time you add a tap, that's what's going to happen, alright? So there we go, in context. Now, alright, so let's identify the correlation coefficient and coefficient of determination. Where is that information? My calculator hasn't told me yet. Let's make it tell us. So remember, I told you can get the least squares regression line from the graph, from the data and statistics page. We can also get it from a calculator. So let's do that. So let's dock. Insert. Calculator. Now we're going to go menu. Statistics. We're still doing stat calculations, okay? So we're still hitting 1 for stat calculations, but now we got that 2 variable statistics, right? This is bivariate data, right? Meaning 2 variables. Yep. Bivariate data, which means it varies according to an explanatory variable and it varies according to a response variable. It is not Bavarian. Also, I like the cream. Okay. What's my X list? My explanatory variable we said was taps. So I go down to zaps. And my Y or my response variable was soda. And then we don't need to change any of this. It's almost the same as the 1 variable data, right? Except for that we just define a different variable in it. We hit OK? And man, it gives us a bunch of clues. Okay? Like, it gives us way more. Let's talk about each of these things. First one, clearly the mean of X. We don't need to add other stuff, but we really like to have the standard deviation of X here. That's very nice. There are 40 X values, right? We have the mean of Y. Also a very useful thing if you think about it, right? What is the mean of Y going to tell you? It gives you the average amount of soda left, depending on, for any given number of taps, it doesn't matter. That's how much overall soda was left. It's interesting, right? Okay. We got the standard deviation of Y, and here we go. That's what we were looking for right there. R. This happens to be yes. None of that. By the way, this correlation coefficient, right? Correlation coefficient. Every single pirate I've ever met, this was their favorite thing we did in statistics.
How many pairs do you know?
Very funny.
All right, so we have now our R value, 0.924. Let's interpret that. So this is correlation coefficient. What is that? It's the pirate's favorite one. It's R. 0.94. I got caught up in my stupid joke. 92. Okay. 92. Okay. What does that tell us about our data? It tells us that there is a extremely strong positive correlation, right? And how do we get our R squared value? We square it. So, R squared, 0.924 squared is exactly 0.853776. So we would say that that is going to be about 85%.
Okay, but
So what do we say about that? Huh?